This is a video for Math 83 having to do with simplifying radical expressions. So the first thing we'll talk about is what we mean by a radical expression. So a radical expression is any expression containing some kind of root. And so this is what we call a root. Kind of looks like a division symbol, but it's got this extra little piece on the end. And sometimes we see a number written up here. Now this number is called the index of the root. It tells us what kind of root we're taking. Typically when the index is 2, that's called a square root. The index is not written. It's not wrong to write a 2 up there if you want to, but typically we leave it off. And when there's nothing there, it is a square root. It's assumed to be a square root. This thing that you're taking the root of, in our case it's assumed to be a number, but it could be anything. There could be variables under a root. That's fine. That thing is called the radicand. Okay, so the way that we find a root is that we're trying to decide what number needs to be raised to this power to get the radicand. So in other words, we're answering a question like, what number needs to be raised to the third power to give us 27? All right. What we're doing there is we're going to take the cube root of 27. So what a root asks you to do is find the number that needs to be raised to this power in order to get the radicand. All right, so the ones that we're going to be doing in this class are going to be fairly simple, especially if they are square roots or cube roots. And if they're not very simple for you to do right away, we'll talk about how to do them in the calculator. Okay, so let's look at some examples of evaluating a root. So let's look at square root of 36. We know it's a square root because we don't see an index. If you want to just remind yourself and put a little 2 up there as an index, that's not wrong. It's just not something we typically do. What we're trying to find here is what number squared gives us 36. So we're trying to answer this question mark right here. Well, you can start just squaring things. We probably could get this pretty easily without doing a whole lot of hunting on our calculator, but what you do if you didn't know this right away is just start squaring some numbers. 1 squared? No, that's 1. 2 squared is 4. 3 squared is 9, and you'd eventually make it to 6. And 6 squared is 36. So the square root of 36 is 6. All right, let's look at the next one. In the next one, I have here the cube root of 81, but that actually is not what we're going to do. We're going to do the fourth root of 81. All right, so what we're looking for here is what number to the fourth power gives us 81. This may not be something you know off the top of your head. We don't usually know fourth roots. We're not very familiar with them a lot of the time. So you may have to start going through some numbers here. And so you just go through numbers and raise them to the fourth power until you get 81. So 1 to the fourth, nope, that's 1. 2 to the fourth, might take a few seconds, but it's 16. 3 to the fourth, that's 81. So the answer here is 3. Because 3 to the fourth is 81, and that is what a fourth root is asking you. What number raised to the fourth power is the radicand? All right, let's look at a couple more. Let's look at square root of negative 25. All right, so again, what we're looking for here is the number that when you square it gives you negative 25. Well, we know what number when we square it gives us 25. That's 5. So we might be tempted to say it's negative 5. Because, well, if 5 squared is 25, negative 5 squared must be negative 25. But remember what squaring means. Squaring means if we want to square negative 5, that's going to give us positive 25, right? And if we want to square positive 5, that's going to give us positive 25. So really there is no way, if you think about it, to square a number, meaning multiply it by itself, give 2 factors of that same number and get a negative number. Because if those numbers are both positive, you get a positive number. Remember that if we're squaring it, the numbers have to be identical. So if the numbers are both negative, we still get a positive number. So there is no way we're going to multiply a number by itself and get a negative number. So in general, square roots of negative numbers are not real numbers. They belong to a group of numbers called the complex numbers. Sometimes a part of the complex numbers, the imaginary numbers. But for our purposes, this thing is not a real number. And that's where you can just stop. The square root of a negative number is not a real number for the rules that the reasons we just talked about. We can't square a number and get a negative number. Okay. Now let's look at the cube root of a negative number, in this case negative 27. Now, a square root gives us problems when we try to take a square root of a negative number because we're squaring things. We have two of the same number multiplied together. So no matter what those numbers are, positive or negative, we're always getting a positive number. If you have three of the numbers multiplied together, though, you can get a negative number. That's perfectly possible. So we're looking here at the number that when we cube it, we get negative 27. Well, let's start cubing things. We cube 1, that's 1 cubed, that's 1. Cube 2, that's 2 times 2 times 2, that's 8. Cube 3, that's 3 times 3, which is 9 times 3 is 27. Okay, so we've got 27, but it can't just be 3 cubed because that's positive 27. It's going to have to be negative 3 times negative 3 times negative 3. And since we have 3 negatives here, we can get a result of negative 27. So the answer here is negative 3. So even roots, it's not a real number if the radicand is negative. Odd roots, it's possible for the radicand to be negative and the root is still a real number. It would just also be negative. All right, so in the next video, we're going to talk about the properties of radicals.